Lattice can be studied from one starting vertex by measuring how far other points are from it, not with ordinary distance first, but with squared distance. When triangles inside the lattice expand into squares, a simple rule keeps the measurements organized so the same pattern can be copied into matching parts of the whole structure. The key idea is that squaring a length changes how scaling works, so the body begins by connecting squared distance to the rule shown in the image. In a lattice, points sit at regular grid positions, so a point can be described by how many steps it moves in each direction away from a chosen starting vertex. Quadrants means squared distance, so in a flat grid, a move of a steps in one direction and b steps in a perpendicular direction has quadrants a squared plus b squared. In a three-dimensional 4 by 4 by 4 lattice, a point that is a steps, b steps, and c steps from the starting vertex has quadrants a squared plus b squared plus c squared. This squared measurement is useful because the sides of right triangles inside the grid can be compared directly to the squares built on those sides. For example, a triangle with perpendicular step lengths a and b has one square built from a, one square built from b, and a larger square related to the slanted side through a squared plus b squared. The function f of x equals x squared says that a length x becomes an area-like value x squared, which is the same kind of change used when a side length becomes the area of a square. If the lattice is scaled so that p represents a doubled version of the original length x, then p equals 2 times x. Solving p equals 2 times x gives x equals p over 2, so substituting into x squared gives f of p equals p squared over 4. The division by 4 appears because squaring a doubled length multiplies the squared measurement by 4, so undoing that doubling requires dividing by 4. This is how the rule keeps information from being lost. The scaled coordinate p still carries the original squared value once the scale factor is accounted for. Inside a 4 by 4 by 4 lattice,